Okay, so this is Shrooly. It's a mushroom growing device that was sold on Kickstarter. I'm not going to go too into the depth of whether or not it's a good purchase, but mine is broken. It's giving me this error message here about COM board fail. And so what I'm going to do here is just try and tear this apart and see what it looks like inside and if I can fix that myself. Okay, let's give you a quick tour of how this works. So the unit seals pretty well. It's got these two plastic panels that come off. On the inside here, this is where the mushrooms would grow. Under this little flap here, there's an air filter for the circulation fan. And over on this side, we have this kind of neat, I think it's inductively powered fan device that slots in to humidify the grow operation. And we've got this sort of membrane-y filter thing that sits in a pool of water, and the fan draws air over that and it uses that to create humidity. There's a strip of LED lights in here that illuminate the mushrooms, but it's also worth noting that this does not have any kind of heat regulation, so you still need to have a location to put this in that holds pretty close to the temperature that your mushrooms fruit at. Okay, so to start with, I'm going to take out these 4 screws that I think are going to hold on the top plate. I suspect that my failed humidity and temperature sensor is actually this thing here, so I'm trying to get to that and see what we find. Okay, so now that I've got those out, I want to see if I can pop this top frame off. Let me just... Okay, so I think it looks like this top frame clips on. I can start to pry this here from the middle, and I can find these little clips. And hopefully if I just run my guitar pick along here. Wow, they don't want to come very easily. Okay, so I'm starting to make some progress here. I've unfortunately realized these little pieces here broke off when they should have been probably pushed in. But not a big deal. I think it'll still go back together pretty well. So let me continue with this disassembly here. Okay, so this is actually not what I was expecting. So it looks like this is our main control board here. Okay, so let's take a break from the disassembly to look at what's on this board. So first off, it's huge and very sparse and really not like any piece of consumer electronics I've taken apart before. Let's start with the port for the incoming power. There must be a power supply board down below that will provide the 12-volt power and route it up through this ribbon cable. There's 3 separate 12-volt lines and a whole bunch of grounds to avoid using heavier cable. And you can see there's a D plus and D minus, which is probably the USB signal coming in. But it's worth noting that there's no lower voltages coming in here, so any lower voltages like the 3.3 needed for the microcontroller must be created on this board. When we look at it, we've got a total of 4 inductors. I'm pretty sure this one in the lower left is part of a regulator for a 3.3 volt supply for all the electronics. And this little circuit over here, I think, is making the 5 volt supply for the LEDs. And so I'm guessing the other circuits create the supply voltages for the e-ink display, but it all seems a little overkill. This connector down here also connects down to the power supply. It's got a speed signal, like a PWM signal that goes to the fan. It's got a tach counter, so presumably it can monitor the speed of that fan. And it also passes 3.3 volt down to the power supply. And it's got an I2C connection. Not really sure what that's for at this point. Up here in the corner, we've got the Espressif ESP32S3 board. This is their little all-in-one room module, which contains all the parts needed for FCC approval, including the antenna, on a single tiny module. This version, I think, has 16 megs of storage and runs at 240 megahertz, and it provides both Bluetooth and Wi-Fi on a single module. Here we got 4 capacitive touch buttons. These get pushed by little pieces of metallic cloth on the underside of the top buttons. I think they just go straight into the ESP, since I think it has the capability on some of its I/O ports to register that. The e-ink screen's mounted here too. I'd also expect to see some kind of driver. Normally you'd use SPI to run that from an ESP32, but it seems to have way too many pins for that, but I don't obviously see another driver chip, so it might be as part of the display module. This connector connects down to the, I presume, broken water level sensor. It looks like another I2C connector, and it also passes 12 volt and 3.3 volt. Then this connector goes to the temperature and humidity sensor board, and that's also I2C. And when we look at that board later, it'll look like I think it's an SHT41 device. If we flip this over, we see a whole ton of test pins, and we also see the two LED strips that are used to light the enclosure. Interestingly, there are two types of LED. The warm white ones look pretty standard, but these guys, when you zoom in, look like they're probably WS2821B NeoPixel color LEDs, and I guess they're all capable of being individually addressed, so you could have sort of a mushroom dance party or similar. Okay, so I've now got the unit upside down, and I'm going to try and get out that water control board. So let's start by taking out these two screws here. And then let's see. I'd expect very much the same clip arrangement as before. Let me just check under the feet and make sure there's no screws under the feet. So these should just lift out, I think. Yes, there's screws under the feet, so let's get those two. Oh, okay, so there's a wire connected here. Oh my goodness, okay, what do we have down here? Okay, so we have another board down here. This has two of the connectors that go up to the top board. So one of these we know transfers power. We have a whole bunch of capacitors here, I think. Capacitors, inductors, why? I don't know why this power supply is so complicated. That seems overkill. Nice that they've put some kind of filler in there to stop it vibrating and buzzing. That's good. But none of this is my water control board. So the water control board is actually over on the other side. So I'm going to take these two connectors out for now so that I can move this out of the way. Okay. Okay, so this I think is my problem board, and it's actually wet. So that, I think, is a large part of my problem here. So, looks like there's another panel that needs to come off. I'm assuming this one's just going to unclip if I take a guitar pick down the side of it here. This guy. Yeah. Okay, so this here is my water level control board, and we can see that it has got some water level issues because the water has actually got onto here. This board is wet to the touch. There's some visible corrosion on this device here, and so hardly surprisingly, that's causing my problem. It's also got this kind of neat little, I assume it's some kind of induction coil that runs the fan. It plugs into this board, but it doesn't actually look like it's plugged in all the way. It's kind of wonky there when I got to it. So let me disconnect that, and I'm going to take this water control board off, and we'll see if we can correct it. Okay, so I cleaned this up a bit, and here's what it looks like. Up here, I think we've got some kind of MOSFET that probably controls the fan coil. Since that's using an inductive coil to move the humidifier fan, I think we probably need to make AC here, which I'm guessing is why there's so many parts. Down at the bottom, we've got a full-on Raspberry Pi 2040 microcontroller. This chip certainly isn't as powerful as the ESP32, but it's still a pretty decent processor and feels a bit overkill, but I guess it costs less than $1. Up here, I think this is an FDC 1004, which is another capacitive sense chip. This is attempting to read the water levels through the plastic, And if we flip the board over, you can see the traces on the back side. Unfortunately, when I put this back in the system, it doesn't work, so I'll give it some more time to dry out thoroughly and see if that makes a difference. Okay, so in tearing this to pieces, I did discover something interesting. If you hold down the support button for a few seconds, it first of all gives you that screen there, and if you keep holding it, it makes a beep and gives you this self-test mode screen that tells you a little bit more about the hardware configuration, and it's got a few options down here. Discovered not to press aging. That seems to like run everything on full blast to simulate some kind of stress test or something like that. But it has this other self-test button down here, which is kind of interesting. And so the first thing in the self-test mode, it seems to go through a button test, so you can test each of the buttons here. And in taking this apart, these use the capacitive sensors on the ESP32, and then they have little pieces of like almost like foil or metallic fabric that get pushed down when you push the button. Interestingly, when you go into the LED test mode, you can actually see, if I can get that button to work, that it can actually run red, green, blue. And so these look like these are probably WS2812B LEDs that are driven here. It probably could also do patterns, I suspect, just looking at the circuit board. And then if we go to next test, we can see the white LED will do different intensities. I've got to get that one first before it let me go to the next test. You can change test the speed of the fan there. So it's 25%, 50%. These buttons are terrible, but there's the fan. The air exchange fan should be running at 100% there. Humidifier test obviously isn't going to work because my Shrooly is broken, but I still have to cycle through those two options. Tells me my ambient temperature and humidity, which looks about right. The water level test, also not very useful. And it gives us our Wi-Fi networks, and self-test is done. So kind of useful to know that it can test some of its internal hardware, although not very useful in this particular case.